Alright, hi guys, welcome to my YouTube channel, and it's your favorite tutor, Sir Steve. And if you are watching this channel for the first time, if you are watching this video for the first time, make sure you like, share and also subscribe to this channel, so that once we post more of our videos, you are going to get them on your phone directly. Also click on the bell button, and that is for the notification, so that once we post our video, you'll be notified either through your Gmail or any of your social media handles. Alright, this year, this is one of the questions I have predicted, and as you can see the question on your screen, saying A is a solution containing 0.01 mole per dm cube of KMnO4, that is potassium permanganate, and B contain 1.37 gram of iron 2 salt, so which dissolves in pure water, making up of 250 centimeter cube of solution. And according to the instruction, you have to put A in the burette and titrate it against 20 centimeter or 25 centimeter of solution B, titrated. Repeat the exercise to obtain consistent titral value, tabulate your reading, and calculate the average volume of A, and that is KMnO4 used. Now we are given an equation, and as you can see on this board, I have the equation here. Now I am not saying this is the right question, I'm not saying this is the actual question for this year, but a very, if not 100% sure, but 99% sure questions that might probably come for this year question. And I've dig deep to make research on this, and I believe you are going to find this video more helpful. So let's quickly get straight to the point. And I believe very many of us knows that the titration for this year is going to be between KMnO4 and FeSO4, where we are going to be using H2SO4 inside FeSO4, that is iron sulfate salt. So according to the question, let's assume after my titration, the volume of acid used, after my titration, volume of KMnO4 used after my titration is 18.10 centimeter cube. I'm only assuming, because different schools have their own different titral value, and take it or leave it. Please, this year, if you are a student and you are watching me, please take note that the titral value of your school might differ from other schools. So different schools might have different titral value. But for this one now, for this video's sake, I am using 18.10 centimeter cube as the titral value. Now, the volume of B used. So the volume of B pipetted is 25.0 centimeter cube. So these are the two values that are fixed. So this is my average titral value for this question, in as much that I'm using this question, and this is 25 centimeter cube of B used. So let me quickly go straight to the question. The question B says that from your results and the information provided, calculate the number of mole of iron 2 which react with 1 mole of manganese dioxide. Now, let me quickly give you that. The B aspects. The question says, calculate the number of mole of iron which react with this. Now, in as much that in our equation we have this, you don't need to panic. This is just your answer. The answer is 5 moles of Fe2 moles. Very simple. Can you see the answer? It's just 5 mole. You can see from the equation by yourself that we have 5 mole for just 1 mole of this. Alright, let's quickly move further. The next question says, calculate the... Alright, according to the next question, which says that calculate the number of mole of manganese used in titration. So the formula to use at this point is mole is equals to molarity times volume over 1000. So what do we do here? According to the question, A is a solution containing 0.01 mole. So we have 0.01. The volume here is 18.10. Why this is over 1000. So the final answer for this is definitely going to be it's going to be 0.0000181 mole. So that's the final answer. Yeah. Alright, the next question says calculate the mass of iron 2 titrated. Calculate the mass of iron 2. But before then, there's a question. Okay, I omitted this question number 3. Says calculate the mole of iron 2 ion titrated. Alright, let's quickly get this. If 1 mole of Alright, check this. Look at this equation. You will get to notice that just 1 mole of this react with 5 mole of iron 2. And this is what I've written. Alright, let's come back to this. You will discover that we have 0.000181 mole. So it means if 1 mole stand as 0.0000181 mole, so it means 5 mole is going to be 5 multiplied by 0.000181. So which is going to give me exactly 0.000905 mole. So this is what I'm going to have. 0.000905 mole. So this is the answer to question number 2. So the question says calculate the mole of iron. So your final answer is just 0.000905 mole of iron 2 was titrated. Very simple. So let's move straight to question Roman figure 4. So this one is the question Roman figure 3. So you can see that. So the question says calculate the mass of iron 2 titrated. Calculate the mass of iron 2 titrated. Now let me quickly give you this formula. Formula for mole. Mole is also giving us this formula. Okay, it's giving us this formula: mass divided by molar mass, or let me use atomic mass. So can we see this? It is mass over atomic mass. Mass over atomic mass. So in as much that we are looking for the mass in gram of this. So what is our mole? Our mole, according to the question, is 0.000905. Now the mass is what we are looking for. Then divided by the atomic mass of iron. Remember that iron is 56. Some scholars will say 55.8, 55 points. So I'm using 56 for this level. So I have 56 here. And what do? When I cross multiply, I have my mass to be equals to 0.0000905 times 56. So let's see our answer multiplied by 56. So I have my answer to be 0.05068 gram. So that's the mass of iron 2 titrated. So what's the next question? The next question says, calculate the total mass of the ion in the original sample of iron 2 salt. Total mass of ion in the original sample of iron 2 salt. So if we want to get the total mass in the original sample, okay, let me use this. Total mass in the original sample. Okay, let me clean this. We already know now the iron 2, when we titrated, the iron 2 that was pipetted was 25 centimeter cube. So remember that we used 25 centimeter cube. The 25 centimeter is the one that owns this iron 2, which is 0.05068 gram. 25 centimeter cube was pipetted. So why this is the ion that is inside this 25 centimeter cube. Alright, so definitely if we are given 25 centimeter cube of this, according to the question, the number of the solution used was 250 centimeter cube. So it means how many are we going to have in 250 centimeter cube? So I don't know it. Let me call it x gram. And remember, when we cross multiply here, our x gram is going to be exactly 0.05068 multiplied by 250 divided by 25. And when we subdivide, this cancel this. So I have 10. My answer is going to be, alright, my answer is going to be 0.5068. 0.5068 gram. It means the ion that we have in that is this. So the next question says, calculate the percentage of ion in the salt. Calculate the percentage of ion in the salt. So that is question Roman figure VI. So this one is standing as question Roman figure V. Please don't get it twisted. From here to here is Roman figure V. See, this is question VI. How do we get the answer to this? If you are looking for the percentage of iron 2 is going to be, how many iron 2 do we have? This is it. 0.5068 divided by, according to the question, they said B contain 1.37 gram. If you notice on the screen, B contain 1.375 gram. So this is 1.375 gram multiplied by 100%. And I hope the answer you are definitely going to get. The answer you're definitely going to get is this. So let me do the calculation. 0.5068. So divided by 1.375. So I have my answer to be 36.858%. So the correct answer to that is 36.858%. I hope you are getting that. So this question might definitely come exactly like this. Exactly like this. So let me quickly go straight to the next part of the theoretical question that I predicted might definitely come. Now take note of all these things. They are predicted questions and not the real question. I repeat, they are predicted questions and not the real question. Alright, let's move straight to the next part. That place that is representing capital letter B. So let me start with the I part. The question says, why was no indicator used in the titration? Why was no indicator used in the titration? Now, in as much that the titration involved KMnO4, what we just need to do is that KMnO4 is a self-indicator. Why was indicator not used in the question? The answer is because KMnO4 is a self-indicator. It is the indicator of itself. It is the one that will serve as its self-indicator. I hope you are getting that. Alright, let's move straight to the next part. The question, Roman figure 2 of that B, says, how do you recognize the end point of the titration? How do you recognize the end point in the titration? Immediately you see the first faint permanent pink. This is the color that will make you understand that we have gotten to the end point. The first faint permanent pink is the one that will make you recognize that this is the end point of the titration. Now another question is, suggest reason why the presence of dilute H sulfuric acid is essential for an accurate titration, and why dilute HCl and nitric acid are unsuitable to be used in the context of this titration. Now the question is suggest why, and that is Roman figure 3 of this part. So you have to suggest the reason. Now number one is when you use let me say when you use H2SO4, let me answer this first. When you use H2SO4, what you are just trying to avoid is you are trying to avoid what is called side reaction. The side reaction is known as the oxidation. The side reaction is known as oxidation of MnO4. So this is what you are just trying to avoid side reaction. Now, when you get the oxidation of this, instead of you to get the end point to be first permanent pink, you are either going to get, you are definitely going to get what is, probably you can get a brown coloration, or it is possible for you to get a black precipitate. Are you getting me now? So immediately you do not use this. If you do not use H2SO4, definitely it is possible for you to get a brown coloration, or definitely get a black precipitate. Now another one is, why is it that HCl is not essential? Why is it that we do not use HCl or we do not use HNO3? Now take note of this. Take note of this. If we use HCl, HCl is going to oxidize. HCl will oxidize. HCl will oxidize MnO4 minus. HCl will oxidize MnO4 minus. That should be the answer. And when HCl oxidizes MnO4, definitely we are going to get what is called false endpoint. let me use this language. We are going to get false endpoint. The false endpoint means we are not going to get the real endpoint. So remember, when this is not used, if this one is not used, definitely we are going to get a false endpoint too. So, and HCl must not be used because HCl oxidizes this HCl design. So why is it that HNO3 is not also used? We use H2SO4. Remember, H2SO4 was used. So why? Another answer to this is HNO3 will never oxidize this. HNO3 is going to oxidize, okay, it will oxidize Fe2 plus to Fe3 plus. Are you getting me now? So HNO3 is going to oxidize Fe2 plus to Fe3 plus. So I believe I take my time to answer all this one. This is a very strategic question of Roman figure 4. Let me clean this. A very strategic question of Roman figure 4 of this. The strategic question of Roman figure 4. Alright. To answer this question, the question says, explain why the upper rim of the meniscus of KMnO4 was red. Now remember, in that burette, normally in as well that it is KMnO4, we are supposed to measure this place, but we are using this part. We are using this part. Now, why is it that we are using this part and not this place? Why are we using this part and not this place? Now, remember that KMnO4 is having a color. It's not colorless like water. If it was water, so if it were to be water, we are going to read this meniscus. But because it is KMnO4, everything is going to be purple color. And it is going to be a dark. So definitely, how do we expect us to see this meniscus? And that is why we need to read from this top. Are you getting me now? So why is it that we do not read that? You will just say that KMnO4. If I were the one in the hall doing this, I would say KMnO4 is a colored solution. Is a colored solution. And opaque to read the lower meniscus. So it is impossible for us to see the lower meniscus because everything will be purple all through. So the lower meniscus, instead of us reading it, we read the upper meniscus. I believe I've done justice to all these questions. I believe I've done that. Now, I would like you to do something for me. Make sure you subscribe. Just click on the subscription button and also like this video. Share this video. I bet it with you, I don't give fake things. It is not the real question. But if not 100% predicted question that is coming this year, let us focus our mind that this is going to be 99% sure that is going to come. Now, this is just the part 1 of this. I'm still going to post the part 2 of this in a way that questions might definitely be asked. Now, if question is not asked like this, of course, I believe that it will be asked in this way, if definitely it is going to be asked. And if it's not asked like this, I will give us the other way at which it is going to be asked. So I believe you really enjoyed this video. Now what I just want you to do is that sit down, study each of the steps, ask questions. Make sure you ask questions, go straight to the comment section, ask your question. Whatever questions that you ask, if you have an addition to it, say it on the comment section. Do not allow the comment section to be boring. Don't forget, make sure you like this video, share the video, also subscribe, and make sure you click on the notification button You can also share among your friends. Thank you for watching. My name still remains Sir Steve, your favorite tutor on this channel. So I believe this year's exam you are not going to fail in Jesus' name. Thank you. God bless you.